green light, good. Objectives are on the board. The Gaussian, if you remember, is going to be that row echelon form. As we're doing the row operations, Corbin, close that please. When we're doing row operations, we're trying to get that diagonal, that main diagonal worth of ones, everything below that 0. That will give us a solution at the end, right? So we're not going to spend all our time doing that because you should have already practiced that sum. What I want you to do is be savvy with your time. So I'm going to let you use the calculators to do that, since you can always use one. We're just going to go ahead and throw matrix into the, of course, matrix feature. We'll run RREF, and then we'll read it from there, and I'll tell you what the results mean. What's up?
In college, could you use calculator?
Yeah, actually in college I was required to have a TI graphing calculator.
Does it matter which one though?
It does matter. They don't like you using CAS systems. So if you're going to invest in a calculator, 83 is the most used, period. I don't know there's a lot of instructors that will use an Inspire. You guys seen Inspires before? They look like the ones in the back. Those are 84s, but they have a different keyboard. You cannot use a TI-89, which is a titanium. That is a CAS system. The CAS systems, between you and I, actually solve equations for you as well. They have solving pictures. No, it's the truth. I have a couple of them, and I use them to check my work sometimes as well. So, because who do I ask, right? So, I ask my CAS. So you'll see them in the back, they'll say CAS systems. Not this one though, these are regular 84s, these will not solve them for you. But TI-89 is a CAS system, and they have two different Inspires. They have a blue version, which is kind of like this, much cleaner, much cooler to work with, but then they have a black one, which is a CAS system. But yes, this is the most used one anywhere. I know, okay? And that's what I'm going to use. So, I'll get there. I'll get there. I'll get there. Here it is. Since the calculator's up, I do want to show you guys something real quick. Let's go here. Someone give me the equation of a circle, please. That sounds good. So, thank you. Waterfalls. So you have one of these on your test, and when we were doing it algebraically, I was working with somebody, and we were doing some solving. We took an equation and we plugged it into this, and we took this from being a circle to being a quadratic equation. And the quadratic equation produces solutions. One of them works, one of them does not work. Okay? So the easiest way to do this is going to be with a calculator, right? But it's harder to graph this thing on a calculator. It's really not. And I'm going to show you, because it has to be in the form of y equals. Here's what you're going to have to do. You're going to have to take x over, and you got y squared is equal to 25 minus x squared. How do I get rid of a square? I'm going to square root. If I do that, when I square root a square, what do I need to add? Plus or minus. And then that can stay the way it is. So in my calculator, I'm going to graph two. I'm going to graph a positive root 25 minus x squared and a negative root 25 minus x squared. One of them will give me the upper half. The other will give me the lower half. So as I go to y equals, let's go ahead and clear that. I'm going to do the root of 25 minus x squared. And then I can do the negative root 25 minus, that's my phone, sorry. So check it out. Now, if you want to see a circle, you're going to have to zoom square this thing because it's not in a square window. But if you want to see in the circular form, we're squared. 5. And then the first equation, oh snap, that's not good. Let's standard this first. 6. Let's just do it in the standard form. So there's the first one, the positive, which is the top half, and then this is the bottom half. Now, of course, this is not a square window, but there's your circle. You see that? And then if I wanted to find the equation that crosses through there, then I would just add a third line. So if I had something like y equals negative x plus 2. So I can graph that. Oops, what did I do? I put minus instead of negative. Noob. So now you can do that. Now, of course, you should know that that is a square, a circle, even though it's not looking circular in nature. But then once you have this, which feature am I going to use? Intersect feature. And you're done. Yeah, because there's only 2 times where it crosses. It'll cross here.
Why didn't you show us that before?
Nobody asked.
Because we didn't know nobody was going to be on there.
We didn't know that it was going to be on the test.
Shame on both of us then.
No.
Hold on, wait a minute. This is not a calculator course. I'm showing you some tips though. Because I see what happened and I saw people.
Mr. Munoz?
You made it come up my nose. Thank you. Waterfalls. So this is why it's important for you guys to come back as well and see me about things. Okay, because sometimes I don't catch things that way. Okay, and we were able to catch it, and now I'm sharing with you something that you can do. Okay. Another big thing that we saw, and it was Carlici that brought it up. On the parabola, you had an inequality parabola, and then you had a linear equation, and they were systems. And for the most part, people are graphing them right. Like, you had a parabola like this and like that, you're supposed to shade inside. Well, a lot of people got that wrong because the scaling on that picture was different. You know, people were going back and thinking, oh, you know, if you move 1, you go up 1, right? And if you go over 2, you go up 4. That's okay if the scaling was by 1s, but the scaling was by 5s, which changed the way the picture's gonna look. Okay? All right, cool. Just some things I want to share with you. Let's go home. Let's go home. Let's just go home. All right, let's get back to what we're doing here. So, here we go. All right, so 2 types of systems. You're going to have a system that is called inconsistent. That means that it has no solutions. If the system is inconsistent, it has no solutions. The other type of system is called a dependent system, and it can have infinitely many. Yes, I think that's the person. Yeah, we're good. What's up, Marsh? Guys, if you need to go to the restroom now, there is a sign-out sheet, so you need to sign out and sign back in. Thank you very much. Do me a favor, Corbin. Skip a line and then add the big thing. Today is the 4th. Go back to inconsistent here.
Yes, let me take a picture of it. Wow, the steam is really good. Those are really good. Thank you.
Okay, so reason I'm not going to have you do all these by hand is that sometimes you're going to sit there and you're going to think you did something wrong. And I remember doing that in college. Like, we had to actually work through, do the row operations, and sometimes I couldn't get those 0s and 1s. It turns out that it was going to be one of those two, the inconsistent or the dependent. So by taking our calculator, plugging it in, we're going to let the calculator do all the plug and chugging, and then it's going to spit something out for us. So go ahead and take this system, plug it into your calculator. I'm going to go ahead and freeze that so I can try to do it over here.
Learn your matrix. Is a 3 by 3. Oh yeah. What is it? 3 by 4? Are they even 3 by 4? 3 by 4. You get that put it in the answer too. Well, because
Please make sure you put this into the matrix right now. I don't want to have to spend more time on this than we need to. Oh, go back, wrong one. Once you have that in there, put your calculator down so I know you're done.
Oh yeah, no, I ended with that.
Put it in the matrix.
Is it?
Did you already do this? Did you run the? Okay.
I got easy to learn.
What'd you get?
Evolving that.
What'd you guys know?
How do you know?
I have no idea.
You're right, but how do you know?
Wait, I'm right on this one. I said 2.
You said there's no solution.
Because the ones aren't
Got the
Oh, I didn't do that.
Looks like we're done. Let me unfreeze this now. Freeze. Okay, so I've got my matrix in. Someone double check my coefficients, please.
what? Oh.
Someone double check my coefficients. I don't want to like do the math and then it's like, I know, that would be like, blah, blah, blah. Yeah, good, carry on. So I'm going to quit. Where am I going here? Second matrix. Math. I want RREF. I'm not even going to mess with Gauss. I'm going to do Gauss-Jordan. And I'm going to do RREF on matrix A. I'm going to get this. And this is supposed to give me, hey, according to this, I'm supposed to get 1x, 1y, right? That whole diagonal of, that main diagonal of 1s. 0 is above, 0 below, which tells me x is this, y is this, z is that. Well, in this case, I don't get that, do I? No, it looks like I got an x and a y, but that's 0. A y and a z and that's 0. But the very bottom line is the most interesting one to me here. What happened at this bottom line? There's nothing. According to this is saying 0 x's plus 0 y's plus 0 z's is 0, right? And they're saying that 0 is equal to 1. Is that true?
No.
When is that true? Never. Therefore, this system is inconsistent.
Hey. At least I can figure it out riddle.
You guys good there? Make that note. Make sure that you can read that. If any one of those lines gives you something that's false like this, then the system is inconsistente. What's up?
How would that look on a graph? And inconsistencies.
On a graph? I don't think you're going to graph this because this is going to be, remember you have 3 variables, right? So remember how we were talking about when we did imaginaries? That you had those 3 axes? This is what that would look like. You would have an x, y, and a z value. So you would have lines that are, you would never do that on paper. If I had my Inspire software, I would do it. Because the Inspire will do 3D graphs.
Stop.
Yeah, you did.
Oh. Actually, that was a reflex. I didn't even. I was even thinking about
You
it.
just got hand sanitizer.
Oh, I didn't even hear the door. I'm not even.
I was like just sitting here. I was like, oh, okay.
My bad. Are we good? I can shake shit? I can shake shit? Hold on. Did you get that? You're okay? Okay.
Yeah, you can change it.
Alright.
I just thought you said something different.
Change it. Questions on how to identify an inconsistent system?
No.
We're good? Alright, cool. Let's move on to this next example. Go ahead and throw this into your matrix. Go ahead and run RREF if you want. That's okay with Simoa.
You did it wrong. Wait, no, wait.
Okay. Sounds like you have it. Sounds like you have it. What did you get as a solution matrix?
And in potion.
1, 0, -11, -11, 13, 0, 1, -5, 4, 0, 0, 0.
Okay. How's this one different from the last one? Are any of those false statements? The last one's false?
Wait, I don't know.
No, zero's equal to 0.
Yeah, so this is definitely not false, right? Do I know these are false? Not really. But this will be the sign that which waterfalls. So the last one versus this one. In the last one, we knew that it was a false statement, therefore no solutions. When you get this, you guys remember those systems when everything eliminated itself, you ended up with 0 = 0? And you said, oh, that's because it was true, but the lines were coinciding, right? Okay, so kind of same idea here. We're getting something that says 0 = 0 at the end, which means this is going to have infinitely many solutions. Okay? Therefore, this is going to be called a dependent system. It is consistent. It's a consistent dependent, and it's going to depend on a specific variable. Okay? So, yes, you're correct, but this is going to depend on the variable. So, you're still going to have to solve this. I don't want to have to go through this whole process of,
What do you mean? Depend on the variable.
yeah, I'll show you right now what I mean. Okay?
Because she goes back so far.
Is that not right?
And like she's
They have a different equation on my list.
I forget what show, bro. I do not like being so
Okay. Waterfalls. So here's what's going to have to happen. Because we do have this equation, this is going to have to depend on one of the variables. And usually it's going to be the variable that they have in common, which is going to be z most of the time. So in this case, we know that the value of y is actually going to be equal to 4 plus 5z. So this would be the solution. What would x be equal to? 13 plus 11z. So you see why it would be considered dependent, because the solution would all be dependent on whatever the value of z is going to be. Okay? What's the solution for z?
Wait, how's the infinite solution?
Because, that's a good question. What's the value for z for starters? Anything. So, depending on what I pick for z, I'll change these values here. And how many options do I have for z? Infinitely many.
So when you said we'll stop to solve it,
Right, so let me tell you what it's going to look like. How do we usually write down a solution for a 3 by 3? It's an ordered set, right? And it goes x, y, z, correct? So here's how you're going to write your answer. What's my value for x? 13 plus 11z, comma, what's my value for y? 4 plus 5z, comma, and my value for z is just z because that is what the system depends on. Questions there?
So that's what you put.
Yeah, that's what you'll put in. Instead of actually having 3 numbers like
so
you
that would be
usually would,
one line?
that would be 1 point on 3 lines. No, wait a minute.
On 3 lines.
No, wait a minute, because this is an infinitely many. This probably would be,
Oh wait, because it's on like a 3D plane.
this is a 3D plane, right? So I'm trying to visualize it in my head. What's up? Waterfalls. What's your question?
Like another, like similar question that has like infinite solutions. See if I can do it by myself.
That was supposed to be, let's see if I have another one here. Oh, that's the other part.
Because it makes
That's
sense
all.
when you do it, but I feel like I will get lost in my own work, so I want to try.
Okay, so let's do this then.
Well, I have a question.
Go ahead.
The one we just did, that one right there.
Yes,
that's,
right here.
That's dependent, right?
This is dependent. What's it depending on?
The variable.
Which variable? Z.
So it has infinite
Z.
amount of solutions.
Right. Yeah, this one's going to be infinite because we saw that here we got a true statement, which means you get 0 equals 0. And technically that's just kind of setting us up saying, hey, you know what, it doesn't matter really what I put in. It's all going to be true no matter what. But what does that depend on? Which is the one that's going to be changing in this case? And in this case, that's why we have to go a step further, create our equation here, look for the common one, and it's usually going to be z. And then we're going to go ahead and solve that. Solve for y, solve for x, and z's are dependent, so it's going to just be z.
So a variable that has like zeros in it, I guess you're saying?
Right, so you're looking for this, for that being infinitely many solutions, versus having this, which was false, having no solutions. That make sense? Okay, go back.
Yeah. Oh, I get it. That's why it's X. Sorry, thinking out loud.
I found, let me see, I just looked for one. 2x, here, write it down for me, so that way I can read it to you.
Is this the solution?
Yes, that's how you type it in.
Oh my gosh, this thing's tall.
2x plus y minus 3z equals 0. 4x plus 2y minus 6z equals 0. X minus y plus z equals 0. Waterfalls. Go ahead and solve this system, please. I'm gonna use my hand to calculate it.
Yeah, that would be interesting. Oh, you doing this one?
Wait, so would this be a 3x4? You just plug in 0 or would it be a 3x4?
It's a 3x4.
You just plug in 0.
But the answer is no, is correct.
Don't spoil it.
Exactly.
Infinite because water is rather than
Okay, here we go.
Do you actually go home and
So you go into town.
twice a day? Yeah, I still need to play more, but I like I like doing it with the moment. Doesn't work. I say it
Oh, no, I know.
Waterfalls. This system is going to produce a bunch of decimals for you. They should look familiar. If those are familiar fractions, then do this. Push the math button. The math button. Select fraction. Push enter. That's going to be much nicer for you.
I've heard this for my whole life. I've been trying to figure out these freaking fractions for my whole life.
Yeah. So what's the solution?
Oh, this is the solution. I'm stupid. I'm here with
you made an error, go to. It'll tell you where you made your error. Yeah, if you didn't have
The
any.
first case that thing like stuttered at a stroke. Oh my god. Gavin fixed those things.
Or you have a decimal.
No, I was
I was trying to say.
Right. But now it's gonna be last. Oh, here. Right now.
Did you say a word to me? Education.ca.
I thought it was a 62. I'm sorry. Now that I'm looking more, I see that it's a 16.
Yeah, I got my really good friends so. I like cars. And I was like, okay, well, I got $10.
I have to try going anywhere. Now it's time to There is no longer a backside. There is one.
Waterfalls. You guys are putting in the calculator and you're spitting out the row of zeros and you're saying it's got infinitely many solutions. That's good. But you still need to go back and get x, y, z. Because it has infinitely many solutions, the system is dependent. Which means that x, y, and z will simply be in the form with a variable in it. Because it's going to depend on one of them. What's up?
I have the answer.
You have x, y, z?
I have X, Y.
What did you get for x, y, z?
X is
Give me x.
13 plus 2/3 Z.
I just got two. Yeah.
Sorry.
Wait.
Wait, 13.
What'd you get? What'd you get for x?
2/3 Z.
2/3 z.
And then for Y, I got 5/3 Z.
5/3 z.
And then for Z, I got Z.
And z should be z. So, when you plug it in the system, you should have gotten, what is it? 1, 0, negative 2/3, 0. And then 0, 1, negative 5/3, 0. And then 0, 0, 0, 0. So Blue, when you do the reduced row echelon,
I didn't mean to say 13.
okay. So when you do the reduced row echelon, everybody got to here. That's fantastic. This row here is telling me that there's infinitely many solutions. But that means it's going to be a dependent system. So I have to retake these guys, translate them. X. How many y's do I have? None. So minus 2/3 z is 0. From this one, I know that y minus 5/3 z is 0. I'm just going to move them over. So x is 2/3 z. When I move this over, y will be equal to 5/3 z, and z will be my dependent variable. Too much red or what?
Huh?
Too much red?
No, it just burned for some reason. Like it just did. I know. No, question. So, does it matter which row you solve for X and Y? The first one is going to be solved for X.
I'm just going to go with the easiest route. Once I write them here, I'm going to look for what they have in common, and I'm going to move that over. Because then I can make that the dependent one.
Well, I guess it makes sense.
So like if they both had x in common and we're missing, one was missing the y and the other one's missing the z, then I would move the x's over and that would be my dependent variable.
Yeah, plus that one doesn't have a Y in it.
Right. Are we done out of time? Alright, so. Alright, so we'll do 8-3 tomorrow then.
We're so scared.
Have a good one.
Why are you so scared?